Hello, welcome to What is Splunk? I'm Chris with Splunk Education. In this module, we'll learn about machine data and learn how operational intelligence can be leveraged to respond to issues in your organization. Machine data is everywhere, constantly flowing from the devices we interact with, from the car we take to work, the buildings we enter, the servers we connect to, even the phone in our pocket, making up for more than 90% of the data accumulated by today's organizations. This data can be in many different formats, some of it structured, some of it not, making it unpredictable and difficult to process. It's easy to see this data as an unruly monster, speaking a language that we can't easily understand. Let's take a look at a scenario from Buttercup Games, a fictional gaming company with offices across the globe. Last week, a customer called support to report having an issue purchasing in-game upgrades for their product, Puppies vs. Zombies. The support console showed that everything should be working correctly, so Tina escalated the issue to Matt in application support. Matt checked all his monitoring tools and came up empty-handed, so he escalated the issue to Richard, the developer. Richard stopped his work on Puppies vs. Zombies 2 to look at his code and run some tests. Not seeing any issues, he got Sue, the system administrator, involved. Sue stopped what she was doing to help Richard sift through the application, web server, and point-of-sale server logs. They established it was not an application error, so they escalated it to Aaron, the database administrator. Aaron started going through the SQL logs. She found a slow query, making it hard for some users to complete their transactions. At this point, nearly 9 hours had passed, and while the issue was found, it still needed to be fixed. And that was just one issue that popped up that day. Now let's see how Buttercup Games could have used their machine data to solve this issue in less time. When the initial support call comes into Tina, it is logged for future use. Tina dispatches the call to Matt. Matt searches the data for events where purchase attempts end in an error. He pinpoints an event that matches the user's experience. That event can be tied to a database query, which can be correlated to an entry in the slow query log, allowing Matt to escalate to Aaron in a matter of minutes without getting anyone else involved. Taking it one step further, what if we could alert when transactions fail, even before the customer calls tech support? If we had some way to pinpoint, correlate, and alert on specific events, we could save our fellow employees many hours and headaches. This is where Splunk comes in. Simply put, Splunk can take any data and add it to an intelligent, searchable index, adding structure to unstructured data and allowing you to extract all sorts of insights into your business. Not just application issues, but security, user behavior, hardware monitoring, sales totals, whatever you can think of doing. It's like having a translator for your machine data monster. We now understand what machine data is and how harnessing it can give you powerful business insights. Splunk Enterprise is an on-premises solution that allows you to search, analyze, and visualize machine data. Splunk Cloud provides scalable access to the tools of Splunk Enterprise with minimal infrastructure requirements. Splunk's primary features make your machine data available, accessible, and usable to everyone in your organization. At the heart of Splunk is the index, which contains your machine data from sources such as servers, network devices, and web applications. Once data is ingested into the index, it is available for searching and analyzing. Search results can be saved to reports, which provide continued insights into your data and can be used to power dashboard panels. Knowledge can be organized into structured datasets, called data models, to allow users to quickly visualize data in Pivot without having to write custom searches. To stay on top of your environment, alerts allow you to set custom triggers, so you're notified and can respond to incidents as soon as they occur. Hello, welcome to Introduction to Splunk. I'm Chris with Splunk Education. Let's look at the main functions of Splunk Enterprise and how they make your machine data available, accessible, and usable to everyone in your organization. At the heart of Splunk is the index. The index collects data from virtually any source and is very important in Splunk. Think of the indexer as a factory and your data as raw materials. As data enters, inspectors go to work. They look at the data to decide how to process it. When they find a match, they label the data with a source type. The workers use that source type to break the data into single events. The timestamps are identified and normalized to a consistent format. The events are then stored in the Splunk index, where they can be searched. By entering a query into the Splunk search bar, you can find events that contain values across multiple data sources, allowing you to analyze and run statistics on the events using the Splunk search language. You can add knowledge objects to your data. These allow you to affect how your data is interpreted, give it classification, add enrichment, normalize it, and save reports for future use. Splunk can proactively monitor all your infrastructure in real time to identify issues, problems, and attacks before they impact your customers and services. You can create alerts to monitor for specific conditions and automatically respond with a variety of actions. Splunk allows you to collect reports and visualizations into dashboards, empowering groups in your organization by giving them the information they need organized into a single pane of glass. Let's take a look at the Splunk web interface. After logging into Splunk Enterprise, we're directed to an app. Apps are pre-configured environments that sit on top of your Splunk Enterprise instance, extending the pre-built knowledge and capabilities. You can think of them as workspaces built to solve a specific use case. The apps you see are defined by a user with a Splunk administrator role. A quick note on roles. Roles determine what a user is able to see, do, and interact with. There are three main roles in Splunk Enterprise: the administrator role, the power role, and the user role. The administrator role is the most powerful, can install apps, ingest data, and create knowledge objects for all users. The power user can create and share knowledge objects with all users of an app and do real-time searches. The user role will only see their own knowledge objects and those that have been shared with them. Splunk Enterprise comes with two apps by default. The Home app gives you a quick place to explore Splunk Enterprise. It allows you to launch and manage other Splunk apps, find documentation, and set a custom dashboard as your default dashboard. Administrators can also add apps and data from here. The other default app is the Search and Reporting app. Hundreds of apps are available on Splunk Base, or you can build your own. I've added a link to Splunk Base to your notes. The Search and Reporting app provides a default interface for searching and analyzing data. There are 8 main components to the Search and Reporting app's interface. The Splunk bar appears on every page in Splunk Enterprise. You can use it to switch between apps, edit your account, view system-level messages, manage and edit your Splunk configuration, monitor the progress of search jobs, and find help. The app bar allows you to navigate the application. The search bar is used to run searches. You type in your search string and hit enter or click the search icon to start a search. The time range picker is used to retrieve events over a specific time period. There is a how-to search panel with links to documentation and a search tutorial. By clicking on the Data Summary button, you get a breakdown of the data indexed by host, source, and source type. We talked earlier about source types being a classification of your data. The source is the file or directory path, network port, or script from which the event originated. And the host is the host name, IP address, or fully qualified domain name of the machine from which the event originated. Table views provide a UI-driven way to explore and prepare your data without using Splunk's search processing language. The Search History menu allows you to view and rerun past searches. We can narrow our search history by entering search terms into the filter window and filter to show searches executed today, over the last 7 days, or over the last 30 days. Now that we're familiar with Splunk's search and reporting app interface, let's take a look at how we can use the Splunk search language to investigate a potential security issue. Let's check in on Caesar, a search expert and knowledge manager at the fictional gaming company Buttercup Games. This morning, Caesar was killing time on his favorite social network when he got a message that made him think that one of the servers might have been hacked. We'll use the search and reporting app to help Caesar see what is happening on the server. The search bar works as you would expect it to. We just enter the information we want to search for. To see if someone is trying to log into our server using bad credentials and failing, we can type failed into the search bar. As we type, the Splunk Search Assistant will display matching terms, contextual matches, and syntax documentation for the search. We only want to see when the failures have happened over the last week, so we select last 7 days in the time range picker. Limiting a search by time is key to getting results faster and is a best practice to use for every search. Once the time range is selected, the search is sent to Splunk, where it becomes a search job. The new search page opens. The interface now contains a Save As menu, search result tabs, search action buttons, a search mode selector, and timeline. The events containing the text we search for show in the event list, and the fields that were extracted show up in the field sidebar. The Save As menu allows us to save our search as a knowledge object. The results populate into the search result tabs depending on the type of search commands used in the search. The Events tab will display the events returned for your search and the fields that were extracted from the events. For a simple search like this, you will usually be presented with this tab by default. The Patterns tab allows you to see patterns in your data, allowing you to get a better understanding of what is happening in your data. If your search is generating statistics or visuals, they will be displayed in the Statistics or the Visualization tabs. If not, links for Instant Pivot, Quick Reports, and search command documentation will be displayed. One quick note: commands that create statistics and visualizations are called transforming commands. These are commands that transform event data into data tables. We will learn more about transforming commands in a future video. Right above the Search Results tab, we can see the total events returned and an option to return a random sample of these events. The search action buttons allow us to edit, send to background, inspect, and delete search jobs. There are icons to pause, stop, share, print, or export a search job. Clicking the share icon, we get a link that we can share with others or bookmark for our own use. By default, a search job will remain active for 10 minutes after it's run. After 10 minutes, Splunk will need to run the job again to return results. A shared search job, on the other hand, will remain active for 7 days and will be readable by everyone, meaning that anyone you share this job with will see the same exact results you did when you first ran it. The export icon will allow you to export events returned from the job in RAW, CSV, XML, or JSON formats. There are 3 search modes you can choose from the search mode selector: fast, smart, and verbose, with fast cutting down on the field information that is returned. Field discovery is disabled for this mode, only returning information on default fields and fields required to fulfill your search. Verbose mode returns as much field and event data as possible, discovering all the fields it can. The default smart mode will toggle behavior based on the type of search you are running. The timeline is a visual representation of events segmented over time. The segments are dynamically decided by the time you chose in the time range picker. In this case, we see a segment for each hour over the last 7 days. By clicking the cursor over the time range and dragging, we can select a specific time range to investigate. Doing so, our event list updates to show just the events selected. We can also use the zoom links to zoom in and out of a selection. Now that Caesar can see the events that failed, let's look at how we can start using the events and fields to help him dig deeper. Let's take a closer look at how to use events in a search. When a search is run, it will return a list of events. We can use returned events to expand our searches and interact with our data. In the events list, the text we searched for is highlighted, and events are returned in a reverse chronological order, showing the newest events first. While time is normalized in your index to a consistent format, the timestamp you see in the events is based off of the time zone you set in your user account. In this example, we see a 3-hour difference displayed for an event with a user setting of Pacific time compared to a user with a setting of Eastern time. Across the bottom of each event, we see selected fields. Currently, we have the default selected fields of host, source, and source type. We will talk more about selected fields in a bit. Rolling over text in an event will highlight it. Clicking on the highlighted text will allow you to add that text to the search, exclude events that contain that text, or launch a new search using the text. Each option has an icon that will open the redefined search into a new browser window. We add password to the search. The search updates in the search bar, and the new events are returned. Clicking on the highlighted text again will allow you to remove it from the search. Selecting the Info button next to an event, we see all the extracted fields for the event, with check marks next to the selected fields. There is a drop-down for event actions and a link for field actions. There are many options when searching terms in Splunk. If we want to cast a wider net for any text that might indicate a failure, we can use a wildcard. Adding an asterisk to the end of the text fail will return any event that starts with the word fail, including fail, failure, and failed. Search terms are not case sensitive, so no matter how we capitalize a value, all results matching the term will be returned. Uppercase booleans of and, or, and not can be used with multiple terms. So if we want to see events with the text failed, but not password, we add a boolean of not. Or all events containing the text failed or password, we use an or boolean. If no boolean is used, and is implied. Boolean operations have an order of evaluation, using not clauses first, then or, and finally and. Parentheses can be used to control the order of evaluation. As an example, by adding parentheses around the or statement in these search terms, Splunk will first evaluate the terms in the parentheses. Exact phrases can be searched by placing the terms in quotes. There might be times when you're looking for results that contain quotes. You can use a backslash character to escape them. Let's look at how to use commands to do more with our search results. Splunk's search language is built from 5 components. Search terms are the foundation of search queries. Commands tell Splunk what we want to do with the search results. This includes creating charts, computing statistics, and formatting. Functions explain how we want to chart, compute, and evaluate the results. Arguments are the variables that we want to apply to the function. And clauses explain how we want results grouped or defined. Let's look at how these are put together into a search. We will talk about the specific components in a little bit, so don't worry if you don't understand what they're doing quite yet. First, we have the search terms. Then, the first search component. You can see that inside this stats command, there is a function of count with an argument of usage. The as is the clause. These two search components are separated by a pipe. We use a pipe to tell Splunk to pass the current results onto the next component. Our existing query searches our web security appliance data in the network index to count the number of visits there have been to prohibited sites from our environment over the last 30 days, then stores that count in a field called visits. By appending a by clause with the CS username field, we can further split the count of these events by individual employees. The search command can be used to filter results at any time in the search pipeline. The command behaves exactly like the search terms before your first pipe, but allows you to filter your results further down the search pipeline. We can use this command with the visits field we created in the stats command to find employees that have violated our web policy more than once this month. While being able to search inside your pipeline is very powerful, remember that if you can filter the items before your first pipe, do it there for better searches. There are some best practices when searching in Splunk. We previously discussed case sensitivity for search terms. Command names, clauses, and functions are also not case sensitive. If a command references a specific value, that value will be case sensitive. As an example, if we want to replace one of our host values using the replace command, it's required that the host value be an exact match, including case. Using time to limit the events returned is the most efficient way to filter events. The less data you have to search, the faster Splunk will be. After time, the default fields of index, source, host, and source type are the most powerful. These fields are extracted at index time, so they will not need to be extracted for each search. The more you tell the search engine, the more likely it is you will get good results. It's better to search for failed password instead of just password. Inclusion is generally better than exclusion. Searching for access denied is better than searching for not access granted. When possible, use the or in operators instead of wildcards. Apply filtering commands as early as possible in your search. Filtering early limits the number of events, making future manipulations of the data faster. Knowledge objects are tools that help you and your users discover and analyze your data. Knowledge objects are grouped into 5 categories: data interpretation, classification, enrichment, normalization, and search time mapping of knowledge called data models. Knowledge objects are useful in Splunk for several reasons. They can be created by one user and shared with other users based on permission settings. They can be saved and reused by multiple people or in multiple apps, and they can be used in a search. These make knowledge objects powerful tools for your Splunk deployment. Knowledge managers are responsible for overseeing knowledge object creation and usage for a Splunk deployment, implementing best practices for naming conventions, normalizing event data, and creating data models for pivot users, keeping the toolbox clean and efficient. Whether or not you're a knowledge manager in your environment, it's important for all Splunk users to know a little about the types of knowledge objects that exist. Let's take a quick look. Some fields are automatically extracted from data based on the selected source type, but additional fields can be manually extracted to add additional insight to your data. Calculated fields are added to events at search time and perform calculations based on the values of existing fields. Event types allow you to categorize events based on search terms. Transactions are groups of conceptually related events that span time. Lookups allow you to add other fields and values to your events not included in the index data. Workflow actions let us create links within events that interact with external resources or narrow our search. Tags allow you to designate descriptive names for key value pairs. They enable you to search for events that contain particular field values. You can think of them as labels for your data. Field aliases give you a way to normalize data over multiple sources. You can assign one or more aliases to any extracted field and apply to fields from a lookup table. And finally, data models are hierarchically structured datasets, which may consist of events, searches, and/or transactions. So far, we've learned how to successfully craft searches that return the events we want. But what if we need to run the search in the future, or we want to share the search with other users? We could make a note of our searches or email them, but that could get messy and annoying. Splunk makes saving and sharing searches simple with reports. From the Save As menu, we select Report. In the Save as Report dialog, we enter a name, optional description, and select whether to display the time range picker or not. Before saving reports, it's best for your organization to define a naming convention. This will keep your reports organized and easy to find. We use a naming convention of the group the report is for, the type of object it is, and a simple description of what the report contains. After saving, we are given the list of additional settings, but let's just view it for now. When a report is run, a fresh set of results is returned. Since we chose to show a time range picker, we can change the range of the events shown. You can access all your reports from the Reports tab in the Application menu. From here, you run the report by clicking on the title or opening it in Search. There is also an Edit menu. There are options to edit description, permissions, schedule, and acceleration. Clone, embed, or delete the report if we have the proper permissions. When a report is created, it is set to display only for the owner who created it. By changing this display setting to App, we can share this report with all other users of the app in which it was created. In this case, search and reporting. By default, the option to display a report in all apps is only available to users with an admin role. Power users are granted read and write permissions on the report. Notice the Run As dialog. This allows the report to either be run as the owner of the report or as the user that is running the report. So, if you have sensitive materials that not all users of your organization should see in your report, and the report is run as owner, the data could be returned to the user. If the report was run as user, only the data that they have access to would be shown. We can schedule the report to run at timed intervals using the Edit Schedule link. Reports can also be created directly from the field sidebar using Quick Reports. We craft a search that returns events where a user tried to purchase an item but got an HTTP error instead. We would like a report showing the top products that the failure happens with. We select the product name field from the field sidebar and select the top values quick report. This report returns statistical information and a chart visualization. From the Save As menu, we select Report. We give it a name and are given options to show the report content as the statistical values and visualization, just the visualization, or just the statistical table. We choose to show just the bar chart, include the time range picker, and save. Sometimes, a visualization will help you use your data to tell a better story. Splunk allows you to visualize your data in many ways. Any search that returns statistical values can be viewed as a chart. Let's take a search from before. Select the source IP field in the field sidebar and select the top values report. Our search string updates to show the new search. And we now have statistical values allowing us to visualize the data in a chart. Hovering over a segment of a chart will display statistics for the segment. There are many types of visualizations in Splunk Enterprise, so it's easy to find the right chart for your data and format it to best tell your story. Charts can be based on numbers, time, and location. Hey Caesar, should web administrators be logging in from these locations? Many visualizations are interactive, allowing us to zoom to specific values or drill down to the events behind the visualization. We can save our visualization as a report or as a dashboard panel. A dashboard is a collection of reports compiled into a single pane of glass, allowing you and your users quick visual access to your data. The Visualizations tab contains options to select a visualization that best fits our data, or customize it using the Format menu. We select a line chart. We would like to show the legend on the left, so we change it in the Format menu. We now have the panel we want, so we select Save As and click Dashboard Panel. We are going to create a new dashboard, so we select New. Give it a memorable title, optional description, permissions, add a panel title, and select to show the visualization in the panel. We hit Save and view the dashboard. Let's add another panel. In this search, we are counting vendor sales by product over the last 7 days. We make sure we're displaying our data in a line chart and save our search as a dashboard panel. We select the sales dashboard we previously created and give the panel a name. We save and view the dashboard. Our dashboard is starting to tell a story, but could use some visual optimization. Selecting Edit, we can now click and drag the panels to organize them. While in edit mode, we have a menu to see and edit the XML source for our dashboard, add panels, add inputs, and select a dark theme for our dashboard. We also have tools on each panel allowing us to edit searches, change visualizations, and modify visualization formats, along with other actions. Let's add another panel to our dashboard. Clicking the Add Panel button, we have the option to create a new panel from a report, clone a panel from a dashboard, or add a pre-built panel. We have a report that uses the Choropleth map visualization to display the products sold by vendors in the United States. We select it from the list and click Add to Dashboard. We place it, close the Add Panel menu, and click Save. We can access and edit all of our dashboards from the Dashboards tab in our app. Hello, welcome to the Using Fields Learning module. I'm Chris with Splunk Education. In this module, Jessica and I will help you learn how to use fields to filter your data to return the results you need. We will learn how to use fields in Splunk's search processing language, as well as the Splunk user interface to further filter your data, which fields are extracted from your data at index versus search time, the difference in persistent and temporary fields, and how to do more with your data through the use of knowledge objects. The field sidebar shows all the fields that were extracted at search time. We see the fields broken down into selected field and interesting field lists. Selected fields are fields of the utmost importance to you. They show up at the top of your fields list and at the bottom of your events. The default fields host, source, and source type are selected by default. Interesting fields are fields that have values in at least 20% of the events. The letter A next to a field denotes a string value. A hash mark denotes a numeral. Clicking on a field, you will see a list of values for the field, a count of the values, and a percentage of the events the value shows up in. You can add a field value pair to your search by clicking on it. Launch quick reports based on the field, and add it to the selected fields list. The available quick reports will be different depending on the returned values, but clicking on one will create a transforming search and display your results as statistical data. When you add a field to the selected fields list, the field will show in the events where it occurs and persist for subsequent searches. You can see all fields for the search by using the All Fields link at the top of the fields list or the More Fields link at the bottom. From here you can filter fields, see number of values, coverage, type, and add a field to the selected fields. You can refine and run more efficient searches by using fields in them. In this example, we're getting events from 3 different source types. We want to limit events returned by looking only at the Linux Secure source type for now. Searching for a field of source type with the value of Linux Secure returns only those events. Field names are case sensitive, while values are not. The operators equal and not equal to can be used with fields of numerical or string values, while greater than or equal to, less than, and less than or equal to operators can be used for fields with numerical values. Fields can also be added to your search by clicking on a value in a fields window. We can see that our mail server host has returned some events. To focus just on our web servers, we can add a not equal operator to a field value pair in our search. As you can see in this search, wildcards can also be used with field searches. We can also use booleans with field value pairs. By removing the is-not-equal operator and adding a boolean of not, Splunk returns the same results. Here we are nesting search terms in parentheses to return events that are not from mail or www1 hosts. For fields containing an IP address, wildcards are subnet and CIDR aware. It's important to understand the difference between the not equal to field operator and the not boolean. They will not always return the same results. As you can see in these example searches, the number of events returned is wildly different. The top search is only returning events where the status field is not 200, while the bottom search returns all events that do not have a field where status equals 200, meaning that if an event does not have a status field at all, it will be included in the results. As an alternative to chaining together several operators, Splunk can also use an in operator. It's used following a field name, with the values we are wanting to include in our results wrapped in parentheses. The fields command can be used to include or exclude fields from your search. Here, we've piped our previous search into a stats command to create a table that displays a count of events by their status. Since the only field values we're using belong to the status field, we can make our search more efficient by adding a fields command, followed by the field to include in the search. Filtering as early as possible in a search is a best practice, so we place this command before the stats command. The fields command uses a plus or minus operator to specify whether a field should be included or excluded. This command defaults to inclusion, so if no operator is specified, the supplied fields will be included in the search. The rename command can be used to rename fields in your search, to give them more meaningful or user-friendly names. Our column headers of status and count are default labels from our field name and our stats command, but some employees in our organization might not find these labels descriptive enough. We pipe to the rename command and supply the field name with an as clause, followed by the new field label. Since this label is a phrase, we wrap it in quotes. We can rename multiple fields with the same command by separating them with a comma. Let's take a look at how Splunk returns fields in search results. We've mentioned that some fields are extracted at index time, while others are extracted at search time. But what does that really mean? When Splunk ingests data into the index, a select number of fields are automatically extracted. These include metadata fields such as host, source, and source type, and internal fields such as time and raw, which contain the event's timestamp and the original raw data of an event. At search time, Field Discovery extracts additional fields from raw event data. Splunk will automatically extract fields from your data based on its assigned source type, as well as key value pairs found in the data. These fields are persistent and will be extracted every time a search is run containing the same search terms, unless you explicitly tell Splunk to not return them. Temporary fields can also be created on an ad hoc basis using commands such as eval. The eval command is used to calculate and manipulate field values. Results of eval commands can be written to a new temporary field at search time, or replace an existing field's values. Let's look at an example using data from the fictional gaming company Buttercup Games. After an initial search of what sites were being misused during business hours, they have added a new web access policy. The usage is broken down into categories of usage types. The boss wants us to query this data to calculate how much internet bandwidth is being used for each usage type. We first use the stats command to find the sum of all bytes used. The resulting report shows the number of bytes used as bytes. This is what we asked for, but converting these values to megabytes would make our report much easier to understand. A web search tells us that a megabyte is 1024 to the power of 2 bytes. So we pipe our search into an eval command that divides the bytes by 1024, then divides the result by 1024 again. Since we used a non-existing field name for the results, a new field of bandwidth is created. The field extractor utility can be used to extract fields from your data that were not automatically extracted for its assigned source type. You can also use commands to extract fields that were not extracted at search time. These commands extract fields from your data using regular expressions, or regex. If you're inexperienced with regex or would like a refresher in its syntax, we recommend you watch our regex overview video. I have added a link to it, as well as the Splunk documentation, to your notes. Now let's hand it over to Jessica to teach us about the erex and rex commands.
While fields extracted with the field extractor are persistent across searches, there might be times where you want to extract values temporarily for the duration of a search. Splunk provides the erex and rex commands for this. The erex command is a lot like automatic field extraction in the field extractor. You give it a sample of values, and Splunk will try to extract what you want. In the game beta logs, we see unextracted data representing character names for our users. We pipe our search into the erex command. Provide a field name to use for the extracted values. Use the from field argument to tell Splunk which field in our data to match on. And use an argument of examples to provide a list of sample data. When the search is run, Splunk builds a regular expression based on the sample data, checks it against the raw event data, and adds matched values to the character field. While the erex command is very handy when you need to get quick results, it can suffer the same issue as automatic field extraction. It only knows what to look for based on the sample you have given it. Using the where command with the isNull function, we can see some character names were missed. Adding more samples to the examples argument will fix this. We can see the regular expression Splunk used to match by clicking on the Jobs menu. Like with the field extractor, erex is a great way to start your regex, but should be checked and edited to match your needs. Information in the Job menu suggests using the rex command with the generated regex. The rex command allows you to use regular expression named capture groups to extract values at search time. It can be used on field values or raw data. The rex command allows you to match multiple groups, resulting in multiple fields. Let's extract both the user and character name values from our game beta data. Here we are using the field of _raw as the field to match on. By default, this field will be used if no field argument is given. Note that running rex over the raw field can have a performance impact. If you already have an extracted field that you can use, always default to using it. We enter a regular expression that we created earlier inside double quotes and run the search. We now have a field of user that includes the email addresses. We continue our expression to return a character field. Behind our capture group, we add an apostrophe, followed by a \s to match the whitespace. To match character name, in our data, we add a character class of upper and lowercase letters and a colon. We use a plus quantifier to match all characters within the class, followed by an apostrophe. We create another capture group named character. Inside this group, we will match one or more of a character class that includes upper and lowercase letters, digits, along with period and dash symbols. Upon running the search, we now have both user and character fields available to us. When choosing to use erex versus rex, keep a few things in mind. Erex is easier to use. You do not need to know regex to use erex, where rex requires it. With erex, you need to provide samples to generate regex. Rex does not require sample data. Erex creates a regular expression for you. You can use these expressions as a starting point with rex. When possible, use rex.
We previously used the eval command to create temporary fields at search time. This command takes the value contained in the bytes field, divides it by 1024 twice to convert it to megabytes, and stores it in a new field called bandwidth. This calculation made our search results much easier to read, but since this is not a persistent field, we will have to manually type out the eval command every time we want to make the conversion, which is not very efficient. Thankfully, there's a better way. By storing this eval command in a calculated field, Splunk will automatically create the field at search time every time a search containing the bytes field is run. There's one thing to keep in mind when creating a calculated field. Calculated fields can only reference fields that are already present in the events returned by a search. In the search we ran earlier, the bytes field is created by another command in the search. For calculated fields to perform correctly, make sure they are configured to reference a field that has already been extracted. Field aliases allow you to assign alternate names to fields in your data. If you have fields from multiple source types, such as user and username, that all contain similar values, you can create a field alias so that the similar values are grouped together. This allows you to search for all values at once in the shared field alias. Field aliases do not replace or remove the original field name, so you can search your data using either the original name or its alias. Lookups allow you to add other fields and values to your events that are not part of the index data. These field value pairs can be configured to automatically append to events in your search at search time, allowing you to add related information to lend additional context to your data. It's important to remember the search time operations order when working with knowledge objects related to fields. Field extractions are evaluated first in the pipeline, followed by field aliases, calculated fields, then lookups. This means that calculated fields can add additional context to extracted fields, since they are evaluated third, but a field alias cannot reference a value from a lookup. Hello, I'm Chris with Splunk Education. In this module, we'll look at how to use scheduled reports and alerts to better automate processes in your deployment. We'll begin with scheduled reports. A scheduled report is a report that runs on a scheduled interval. Every time a scheduled report is run, It can automatically be sent by email or trigger additional actions. They can also be used to power dashboard panels to prevent Splunk from running multiple concurrent ad hoc searches. Meet Dan, a sales employee from the fictional gaming company Buttercup Games. Every Monday, he needs to report on the previous week's product sales numbers in order to monitor the progress his team is making with the new sales strategy.
Rather than run this report manually every time, he would like to set it up to run automatically. A scheduled report is the perfect solution for Dan's reporting needs. To create our scheduled report, we first start with a search we want the report to be based on. From the Save As menu, select Report. Give the report a name. We also have the option of adding a time range picker to the report. Since this report will be scheduled, there's no reason to include the picker. After we create our report, we select the Schedule option from the Additional Settings links. The Edit Schedule window now opens. Select Schedule Report and the frequency to run the report. For our sales report, Dan needs it to run every week on Monday at 6 a.m. Then we select the time range that the report will cover. Typically, the time range is relative to the schedule. Since we need to run the report every week, we set our time range to return events from over the last 7 days. Running concurrent reports, and the searches behind them, can put a demand on your system hardware, even if everything is configured to the recommended specs. Splunk has settings that allow us to set schedule priority for scheduled searches and set a time window that they may run in. These help us manage our scheduled reports so that they put less strain on our deployment. Schedule priority is only available to admin users and allows us to choose between default, higher, and highest. Giving a scheduled report a greater priority will make sure that they take priority over other searches being run on the system at that time. The schedule window settings allow us to set a time frame in which to run our report. So, if we have other reports scheduled to run at the same time, we can provide a window in which to run a report. This provides some timing flexibility as to when the report is actually executed. If the system is busy, our report will be delayed as long as it falls within our acceptable window. You would include a schedule window only if the report doesn't have to start at a specific time and you're okay with the delay. Setting the window to auto will allow Splunk to automatically determine the best time window in which to run the report. Next, we can choose what actions to trigger when a scheduled report is run. There are options for logging an event to a Splunk receiver endpoint, outputting results to a lookup, sending results to a telemetry endpoint, running a script, sending an email, and posting to an external URL. Splunk also lets you install or build custom alert actions depending on your user role. Admin users will have the option to manage and add pre-built alert actions by selecting Manage Actions. We have added a link in your notes to courses and documentation on building your own actions. Dan would like to receive this report via email, so we will add that trigger action to the report. We select Send Email. This is configured by entering one or more addresses in the To field separated by a comma. We set the priority and can customize the subject and message sent in the email by using tokens. Here we are supplying the name of the report, but there are many tokens that can be used. I have added a link in the notes to documentation on the available tokens. There are options of what to include in the email. These include links to the report and results, search string run, and documents to attach. We have the option to send the email in HTML and/or plain text format. Clicking Save, our report is scheduled, and Dan will start getting his report first thing every Monday morning. Managing scheduled reports can be done from the Searches, Reports, and Alerts link in the Settings drop-down menu. We get a quick overview of our report, including when it is scheduled to run next. Clicking the name of the report, we get quick access to change the search string and time range. The Edit action next to the name of our report allows us to edit the search, permissions, schedule, acceleration, and summary indexing for the report. We can also disable, clone, embed, move, or delete our report. We can also access report management from the Reports tab in the Search and Reporting app. Clicking on the name of the report in this window will display the results of our scheduled report. We can use the Edit button to change settings from this location. Users with a power role have the option to display this report for themselves or other users of the app. In this case, Search and Reporting. Displaying a report for all apps requires an admin role. Selecting App allows us to grant read and write access to all users in our organization or users based on their role. Dan would like to make this report available to folks at Buttercup Games that do not have access to the Splunk instance. We can do this by using the Embed option. Clicking on Edit and then Embed, we can enable embedding for the report. Please be very cautious when doing this. An embedded report will be viewable by anyone that has access to the web page that it is inserted in. We click Enable Embedding and are given the code for an iframe that we can use on any HTML page. Please note that an embedded report will not show data until the scheduled search is run. Once embedding is enabled, we will no longer be able to edit attributes for the report. There's also an option to add a scheduled report to a dashboard. Splunk alerts are based on searches that run on a scheduled interval or in real time. You can have Splunk alert you when the results of the search meet a defined condition. Alerts are triggered once the search is completed. Based on your needs, alerts can list in the Splunk interface, log the event, be outputted to a lookup, send to a telemetry endpoint, run scripts, send emails, use webhooks, or run a custom alert. We create an alert by first defining a search. We are going to search for any 500 errors on our web servers. From the Save As link, we choose Alert. We enter a title. Next, we set the alert permissions. We can choose between private and shared in app. When set to private, only you can access, edit, and view the alert. When shared in app is selected, the results will be displayed for all users of the app. By default, everyone has read access and power users have write access to the alert. There are two alert types to choose from: scheduled and real-time. A scheduled alert type allows you to set a schedule and time range for the search to be run. You can select from a predefined time range or use a cron expression. The real-time type will run the search continuously in the background. As soon as alert conditions are satisfied, an action is triggered. Since real-time alerts run continuously, they can place more overhead on system performance. We would like to know as soon as our trigger condition is met, so a real-time alert type is a better fit. Next, we set the trigger condition that will cause our alert to fire. You can set alerts to trigger per result, after a defined number of results, after a defined number of hosts are returned, after a defined number of sources are returned, or with custom conditions you define using the Splunk search language. Since many issues may lead to a 500 error on a web server, like a bump in the network or a server update, we would like to confirm a problem before sending an alert. For this, we select the number of results trigger condition. We want to be alerted if an error is returned more than once, so we select greater than from the dropdown and enter 1 for the number of results. We then select the time range for the events to happen in before triggering the alert. We set the alert to trigger if more than one error happens within 60 minutes. Because alerts are so incredibly useful, it could be easy to inundate users with alerts, allowing them to be ignored or filtered out. To help keep this from happening, we can set the number of times to trigger the alert using the trigger setting, and throttle how often the alert is executed. If we select the option to trigger the action once, the action will only be fired once within the scheduled time we have selected. If we select for each result, it will be fired every time our conditions are met. As an example, our alert is set to trigger every time 2 or more errors happen within 60 minutes. If we have 6 errors happen in that 60 minutes, we will get 5 emails if we select actions for each result. We will only get 1 email if set to once. We can make these settings more granular using the throttle checkbox. Here, we can suppress based off of field values or time intervals. Alert actions allow you to respond to triggered alerts. Continuing to edit our current alert, we select the actions we want to happen when the trigger conditions are met. We have a choice of actions to take when an alert is triggered. The options will be a little different depending on user role. The Triggered Alerts action allows us to set the severity of the alert, which allows us to sort and filter alerts in the Triggered Alert list. If you have proper capabilities, you can use a log event action. Log events are sent to your Splunk deployment for indexing. We enter the event information that will be written to the log, the source type, and host for the alert, and the target index for the log event. The output results to a lookup option will create or update a CSV lookup table. We can choose to append or replace the data in the lookup table. Using the output to telemetry endpoint allows us to set a name, input field, select the data type, set categories, and opt-in. The Run a Script action will trigger a shell script or bash file stored on your instance. This action is officially deprecated, and we suggest using a custom alert action instead. With the Send Email action, you can set where to send email, priority, subject, message, what elements to include, and to send in HTML and/or plain text. You can use Splunk tokens to add dynamic data to the email. Webhooks allow you to define custom callbacks on a particular web resource. For instance, you can set up a webhook to make an alert message pop up in a chat room, or create a ticket in a support app. Splunk also allows you to install or build custom alert actions. Admin users can find pre-built alert actions by clicking the Manage Alert Actions link. If there's not an action that fits your needs, you can build your own. I have added a link to the alert actions available on Splunkbase and documentation on creating your own. We choose to use a triggered alert, click Save, and view the alert. Since we elected to have alerts listed in Triggered Alerts, we can see any time an alert was triggered by going to Triggered Alerts in the Activity menu. From here, we can view the results and edit the search that defines the alert. We can manage alerts the same way we did scheduled reports by accessing the Settings and Searches, Reports, and Alerts links. Alerts can also be viewed and edited from the Alerts menu in the Search and Reporting app. On the Alerts page, we can see an alert's title, available actions, the owner of the alert's app, who the alert is shared with, and whether the alert is enabled or disabled. Additional information about an alert can be viewed by expanding it, and we have direct links to edit permissions, settings for the alert type, trigger conditions, and alert actions, provided we have edit permissions for the selected alert. We can open this alert in Search, or use the Edit menu to edit the alert, edit permissions, disable, clone, or delete it. The Edit Permissions dialog should look familiar, as it contains the same settings we saw when editing permissions on a report. Alerts are private by default, but can be displayed for all users of the app, or in all apps. Allowing all apps to display an alert requires an admin role. Selecting App allows us to grant read and write access to all users in our organization or users based on their role. Hello, welcome to the Visualizations Learning module. I'm Chris with Splunk Education. In this module, you'll learn how to visualize and format your data into tables and charts using Splunk's search processing language commands as well as the Splunk web interface. Let's begin by learning how to use some basic formatting commands.
The fields command allows you to include or exclude specific fields from search results. This can be handy when you need to limit the fields displayed and can make a search run faster. To include a field, we pipe our search terms into the fields command with the fields we want to include as the arguments. As you can see, this search returns only the fields product name and price. To exclude a field, we use a minus sign between the fields command and the field names. When this is done, the product name and price fields are removed from the fields list. In our search, there's a space between the minus operator and the field names. This causes all field names to be affected by the operator. If we remove the space, the operator only affects the field directly behind it. When we run this search, we see that only the price field remains. The fields command defaults to inclusion, so while our product name field will be removed, a lack of operator tells Splunk to only include the specified field. Internal Splunk fields like raw and time will always be extracted, but you can remove them from the displayed results by using the fields minus command. Field extraction is one of the most costly parts of search. Since field inclusion occurs before field extraction, limiting fields extracted can make your searches more efficient. The table command is similar to the fields command in that specified fields are kept in your results. The table command is different in that it is a transforming command that retains the data in a tabulated format.
By entering the table command followed by session ID, product name, and price fields, we get an easy-to-read table. This table shows which products a user session successfully purchased and for what price. Column headers are field names, rows are values, and each row represents an event. Columns are in the order given in the arguments. To rearrange columns, all we do is change the order of the arguments.
The fields command can be used with the table command to improve the efficiency of this search. Since our goal is to return a table that only uses the session ID, price, and product name fields, we can add the fields command to limit our search to just return these fields. If we exclude any of the required fields before piping to the table command, Splunk is unable to display that field's values in the table. You can use the dedupe command to remove duplicate events from the results that share common values. First, let's add our session ID field back to the fields command so that our table displays correctly. That's better. In our table, we see what appear to be duplicate events. These events represent multiple actions a user has taken in our web store over the session, such as viewing a product, adding it to their cart, and purchasing it. For the purposes of this table, we do not need these duplicate entries, so we will pipe to a dedupe command with the unique session ID values. So each session is only represented once. You can filter your results based on a single field, or for a combination of values among several fields. When using the dedupe command, it's important to supply the correct field names for the events you wish to display. If we remove the JSessionID field and only dedupe on the price field, we limit our table to just one event per price value, which is not the result we were looking for. The add totals command by default will compute the sum of all numeric fields for each row and create a total column. We have been asked to create a table displaying retail sales for each product sold in the United States and Canada over the last 7 days. We pipe to a chart command to calculate the total sum of all purchases for each unique product per country. Let's take our search and pipe to the add totals command. We see that Splunk has added a total column containing the sum of the rows. We can create a column summary by setting the call variable to true. Notice that the row that was created is not labeled. We add a label by setting the label variable with the name to use and the label field variable with the field to show the label in. We can change the label for our row totals using the field name variable. To remove the totals by product and only see totals by country, we can set the row variable to false. The field format command can be used if you want to format the appearance of values without making a change to the underlying raw data. Here we have a table of retail sales by product for all countries over the last 7 days. While this table contains helpful information, it's a little difficult to read. We can clean it up by using the field format command. We will overwrite the existing values in the total field by adding a $sign, then using the toString function to convert the numeric value to a string, and supply an optional argument to format it with commas. It's important to remember that while the field format command creates new field values, the underlying data in your index does not change. All this magic happens in Splunk's user interface. Splunk allows you to visualize your data in many ways. Any search that returns statistical values can be viewed as a chart. As an example, if we take this search that returns the number of games purchased through vendors and click the Visualization tab, we get a chart of our data. Here we see the data in a line chart, which is not very helpful. But if we change it to a column graph in the Visualization menu, things become much clearer. You can roll over the chart to see the count totals for each column, and click on a column to drill down to the events represented by the graph. Most visualizations require results structured as tables, with at least 2 columns. If we look at our search in the Statistics tab, we see 2 columns, also referred to as a single series. The first column provides the x-axis values, while the second column provides the y. Splunk's transforming commands order search results into a data table that can be used for statistical purposes. You'll need them if you want to transform your search results into visualizations. Let's take a look at a couple of these commands, starting with the top command. The top command finds the most common values of given fields in a results set. If we want to find which vendors have sold the most products this week, we pipe a search of the vendor sales source type into the top command, using the vendor field as the argument. The top command automatically returns count and percent columns and limits the results to the top 10 vendors by default. To get more or less than 10 results, a limit clause can be added. To get all results, a limit of 0 is added. You can also use the top command over multiple fields. If we add the product name field to our search, we can see the top results for both vendor and product name. Clauses can also be used with the top command to change the titles of the count and percentage columns, or to not show them at all, and to add a row of count numbers for results not within the limit. Let's search for the top 5 vendors that made the most sales this week. We do not care about the percentage, so we remove it using a value of false for show percent. Rename the count field to number of sales, and add a row for the number of sales for vendors not listed in the top 5. There might be times when you want to show top results split by another field. We can do this with a by clause. Let's say we want to search for the top 3 products sold by each vendor in the last 7 days. Again, we'll rename the count field to number of sales. We don't need to see the percentage, so we remove that from the results. Now we can see the top 3 products sold by each vendor. The rare command has the same options as the top command, but it shows the least common values of a field set. So by changing the search we used for the top command to rare, we get the vendors who have sold the least amount of product this week. We can also use the by clause to return the 3 games that sold the least by each of our vendors. To produce statistics from our search results, we use the stats command. Some of the common stats functions are count, distinct count, sum, average, min, max, list, and values. Individual functions of the stats command are out of scope of this module, but I have added links to the Splunk documentation as well as related modules to Splunk education in your notes.
To find the total number of vendor sales in the last week, we pipe a search of vendor sales into the stats command with a count function. As you can see, the count function creates a column labeled count, which is not very helpful. To change the name of the count column, we use an as clause, like we did with the rename command. To find all the vendor sales by game title, we use the by clause. The by clause returns a count for each field value of the named fields. You can add any number of fields to split the count by.
By adding a field as an argument to the count function, we can get a count of the number of events where the field is present. The chart command can take two clause statements, over and by. The over clause tells Splunk which fields you want to be on the x-axis. Any stats function can be applied to the chart command. To see this in action, let's search our weblog for any errors and tally how many times each type of error happens by adding the over clause to the status field. When we look at our results as a column chart, we see statuses on the x-axis with the count on the y. The y-axis should always be numeric so that it can be charted. The by clause comes into play when we want to split our data by an additional field. Let's take our previous search and split the data by which host the error occurred on. Adding by host to our search, Splunk creates columns for each of our hosts. Unlike the stats command, only one value can be specified after the by modifier when using the over clause. If two by clauses are used without the over clause, the first field will be used as the over clause. Now that we have multiple items in our legend, if we hover over them, we can see the field values highlighted across the graph. Let's get a count for unsuccessful shopping cart transactions over the last 7 days, per host, and split the data by product. As you can see, the null data skews the results. This is because there are events where a product name is not present in the event, so a null value is used. To remove the nulls, we can add an argument of useNull equals f, or false, to our chart command. While this does remove the null column from our chart, in this case it would be much more efficient to remove all null items before piping to the chart command in the first place. The chart command, by default, is limited to 10 columns. Others can be included with a limit argument, but by default show up as other in your events. The other column can also be removed by using an argument of useOther equals f. The useNull and useOther arguments default to true. So if an argument is not specified, these events will be included in search results. Using a limit argument, we can adjust the number of plotted series shown. In this case, the number of products. Or we can use a value of 0 to display all products. The time chart command performs stats aggregations against time. Time is always the x-axis. We can see a timeline of vendor sales by piping the search terms into the time chart command with a function of count. By looking at the data as a line chart, we can see the number of sales over the time of the sales. In this case, 7 days. By rolling over the timeline, we can see the count by specific day. We can also split the data with a by clause to see timelines for each product. Similar to the chart command, any stats function can be applied to the time chart command. Only one value can be specified after the by modifier. The limit, useOther, and useNull options are also available to time chart.
The time chart command intelligently clusters data in time intervals dependent on the time range selected. If you roll over the chart, you will see that the data is clustered by 24-hour groups. To change the span of the time of the cluster, you can use an argument of span with the time to group by. Now when we roll over the graph, we can see the data is now in 12-hour groups. The trendline command computes moving averages of field values, giving you a clearer understanding of how your data is trending. Let's use trendline to see a trend of our sales over the last 7 days. The trendline command requires 3 arguments. The trend type. You have choices of simple moving average, exponential moving average, and weighted moving average, also known as SMA, EMA, and WMA. The SMA, EMA, and WMA compute the sum of data points over a period of time. The WMA and EMA assign a heavier weighting to more current data points. You need to define a period of time to use for computing the trend. This needs to be an integer between 2 and 10,000. In this case, we're searching over the last 7 days, so a value of 2 will compute a trend over the last 2 days. Lastly, we need to define the field to calculate the trend from. Now we can run the search. We can see data for both the sales and trend and can visualize them in a chart. As you can see, transforming commands are a pretty deep topic. Let's have a quick summary of what we've learned so far. If you want to count the frequency of fields, use the top or rare commands. Use the stats command to calculate statistics between 2 or more fields when you do not need the data to be time-based. Use the chart command when you want to calculate statistics with an arbitrary field as your x-axis that is not time. Using the by modifier, each column represents a distinct value of the field we are splitting by. If you need to calculate statistics with time as the x-axis, use time chart. Time chart also allows you to split data by a field. There are several options for representing data that includes geographic information. Splunk includes commands that let you pull geographic data from your machine data, and visualizations to display the data in an easy-to-understand format. Marker maps plot geographic coordinates as interactive markers on a world map, while choropleth maps use shading to show relative metrics for predefined geographic regions. The IP location command is used to look up and add location information from a third-party database to an event. Data such as city, country, region, latitude, and longitude can be added to events that include external IP addresses. Here we are searching the index for users that logged into our servers from IPs outside of our internal network. Piping the events into the IP location command. With the src IP field as the argument, we now see location fields created by the IP location command. These include fields that can be used with the geostats command for mapping. Please note, some location information may not be available for particular IP addresses. This is the nature of geolocation and should be taken into consideration when searching your data. If an address is not found in the third-party database, such as an internal IP address, no fields will be added to the event. If you're collecting geographical data, you can use the geostats command to aggregate the data for use on a map. The geostats command uses the same functions as the stats command. If we pipe our vendor sales into the geostats command with the required latitude and longitude values and do a count, Splunk returns data clustered by location that we can use on a map. We use a lat field argument for latitude and a long field argument for longitude. The geostats command allows you to split your data using the by argument. Unlike the stats command, the geostats command only accepts one by argument. To control the column count, a global limit argument can be used. As mentioned before, you can look up geographical data to use with geostats using the IP location command. Let's take our search from before and pipe it into the geostats command with a count function. We use the lat and lon fields created by the IP location command. These are the default values for the lat field and long field arguments. If you have a lookup table with a list of private addresses, you can replace those field names with values from the lookup. We can now see the locations that employees are accessing the servers from. Hey security guy, does this look right to you? A choropleth map is another way to see your data as a geographical visualization. They allow us to use shading to show relative metrics over predefined locations of a map. In order to use choropleth, you'll need a KMZ, or compressed keyhole markup language file, that defines region boundaries. Splunk ships with two KMZ files, GeoUS States for the United States and GeoCountries for the countries of the world, but other KMZ files may be used. To prepare our events for use in a choropleth, we use the geom command. The geom command adds a field to our events that includes geographical data structures that match polygons on our map. To see it in action, let's search for vendor sales for our vendors in Europe over the last 7 days. We pipe the results into the geom command, followed by the name of the KMZ file, also known as the feature collection. A feature ID field argument is required. In this example, we're using a field with values that map back to the country name in the feature collection. When we run the search, we can see in the Statistics tab that we have a geom table of polygonal data. When we display this information as a choropleth visualization, the polygons are rendered over the map and colors are assigned to the data points. When your results contain a single value, there are two different types of visualizations you can use to display them: single value and gauges. The single value graph displays a single integer. Formatting allows you to add caption text under the visualization, add color based on numerical ranges, and change format of the numbers, including adding information before or after the value. You can also use a time chart command to add a trend and sparkline to the visualization. We are given a single value for the sum of items sold for the last day, and trend and sparklines comparing the results to the previous days. In this case, due to our search being over the last 7 days, totals for each day were automatically used to derive the trend and sparklines. But formatting allows you to choose the time samples and remove the sparkline. The trellis option allows us to split our visualizations by a selected field or aggregation. In our current search, we are getting a sum of all web sales. We append a by clause to tell Splunk to split our results by product name, expand the trellis menu, and select Use Trellis Layout. Now we see individual visualizations for each of our products. While multiple visualizations are displayed, the originating search is only run once. The radial, filler, and marker gauges can be used with single values by selecting them from the Visualizations menu. You can set range segments using format options, or you can pipe the events into a gauge command to set ranges using the Splunk search language. The color of the gauge can be changed in the Format dropdown. Since more sales are a good thing, we're going to change the color ranges to better suit the data. Once the color range format is set, it stays persistent over the radial, filler, or marker gauges. Let's explore some additional formatting options in Splunk, beginning with statistical tables. After running a search using a transforming command, we see a format link in the Statistics tab. We have options to wrap results, show row numbers, change the click selection from cell to row, and add a data overlay. The data overlay can be a heat map of values or highlight the high and low values in the table. The Summary tab allows us to add totals and percentages to columns. When selecting totals, numerical totals for a column are added up and displayed in a new row at the bottom of the table. The percentage option will compute the percentage for each column and create a new row at the bottom of the table. The chart overlay setting comes in very handy when using Trendline. Let's look at a search we ran in a previous segment. This column chart displaying our web sales data uses the time chart command to get a sum of all products sold over the last 7 days, then pipes to the Trendline command to see the trend of those sales. We open the Format menu, select Chart Overlay, and have options to either overlay our sales or trend values. Selecting Trend overlays a line graph of trends in our data on top of the column chart displaying sales. The Format menu contains different options depending on the visualization type. This column chart visualization has options for the X and Y axis, chart overlay, and legend. Whereas this single value visualization has format options for color and number format.